Welcome to Chemistry with Dr. Z. And this video, I'm going to talk to you about uncertainty, atom economy, and calculation of yields. In your exam, you might be asked to calculate the uncertainty of your results or of your calculation. So you should know that and remember that all measurements have some uncertainty to them. So every time you repeat an experiment, you will get a slightly different value, and this is due to what we call the random error. And that means there is some uncertainty. So you are not 100% certain that the value you are getting is the correct one. Experiments should always be repeated at least 3 times. And when you repeat your experiment, of course, you always exclude the outliers or the value that seems to be far away from the other values. And then the remaining ones, which are closer to each other, you find the mean for these values. And then you can calculate the uncertainty of your values. So to calculate the uncertainty, you need to find the range. So the range is the difference between the highest value and the lowest value of all of the values you've got after excluding the outliers. So uncertainty will equal the range divided by 2. Of course, the bigger the value of the range, the difference between the largest and the smallest value, the higher the certainty will be. So let's have an example and see how to calculate the uncertainty. And when you calculate the uncertainty, you use the simple plus or minus next to before you put the value of the uncertainty. So let's have an example to understand this. So in a repeated experiment, you got the following results: 20.10, 19.80, 20.00. Calculate the uncertainty. The uncertainty is calculated for the average or for the mean. So you don't just put the value of the uncertainty, but you have to put the value of the mean as well. So the first thing you need to calculate the mean of all of your results. So the mean is the total divided by the number of results. So the total of all of these three values divided by 3, you're going to find the mean equals 19.97. And then you need to calculate the range in order to calculate the uncertainty. So the highest value is 20.10, the lowest is 19.80. When you subtract these from each other, you're gonna find 20.10 minus 19.80. So the range is 0.30. And then you can calculate the uncertainty, which equals the range divided by 2, so 0.15. So the uncertainty of the mean, this is how you do your or express your values. So uncertainty of the mean will equal the mean that we find, which is 19.97, plus or minus the value of the uncertainty, which is 0.15. So this is how to write your answer when you are asked to calculate the uncertainty. You don't just put the value of the uncertainty, you need to put the mean or the average, and you need to put the symbol plus or minus. The next topic we are going to talk about is the atom economy. So what do we mean by atom economy? In chemical reactions, more than one product is mostly formed. We don't end up with only one product. And not all the products are useful. So atom economy will give you a percentage of how many or what is the percentage of the atoms, total atoms of the reactants was actually used to make the useful product. So we are focusing here on the useful product. So atom economy of a reaction tells you how much of the mass of the reactants were used to make the useful product and how much was actually a waste. To do or to calculate the atom economy, we need to find the relative formula mass of the desired product. if it's only one product, then we are only calculating the relative formula mass of the desired product. If there are more than one, then the total of the desired product divided by the relative formula mass of all reactants. And then we multiply this by 100. So 100% atom economy means that all the atoms of the reactant were used to make the useful product. So this is a quite economic reaction. So let's have an example and see how can we calculate the atom economy. So we need to calculate the atom economy of the following reaction to make hydrogen gas. That means the useful product here is the hydrogen gas. The reaction is the methane gas reaction between methane gas and water to give you carbon monoxide and hydrogen. We will only focus on the hydrogen as a useful product. So the first thing we need to do is to identify the desired product, which is the hydrogen. The second thing, we need the reaction to be the equation to be balanced. So balancing your equation is very important when you calculate the atom economy. The second step is to work out the formula mass of all desired product. So the desired product here is hydrogen, and we have three hydrogen molecules produced from this reaction. That means the MR of the desired all the desired products will equal 3 times 2, which is 3 molecules of H2, which has the relative atomic mass of 2. So the total is 6. And then the third step is to work out the formula mass of all the reactants. So we have one molecule of methane and one molecule of water. We need to calculate the total MR of all the reactant. So methane has the relative formula mass of methane is 16, 12 plus 4, so 16 plus, and water is 18. So in total, this is 34. And now we need to calculate the last step is to use this formula to calculate the atom economy. So atom economy here will equal the relative formula mass of the desired product, which is 6, divided by the relative formula mass of all the reactants, which is 34 times 100, and you end up with 17.6%. So this reaction has really low atom economy because only 17.6 of the total atoms of the reactants were used to make the product or the desired product, which is the hydrogen. So why is it important to calculate the atom economy? Does it have any implications? Of course it does. So first of all, it has implications on the environment. So why implication on the environment? So reactions which have low atom economy means that they have a lot of waste. And if they have a lot of waste, we need to get rid of that waste, which might be harmful to the environment. So this is one thing. The other thing that because we have really low atom economy, that means that we are using a lot of resources to make a small quantity of a desired product. And if these resources are non-renewable, that makes this reaction unsustainable. So for the sustainability of our reaction, we need to have better atom economy. So we are using non-renewable resources or finite resources to make small quantity of a desired product. The second effect is the effect on or implication on profit. So low atom economy means that your reaction is non-profitable. The reason behind this, because first of all, you use a lot of raw material or the reactants you use, which can cost you a lot of money. So if you're using a lot of resources to make smaller quantity of a product or a desired product, then there is a lot of cost here and less profit. The second thing, if you are making reactions with low atom economy, meaning that you might have a lot of waste and you need to get rid of that waste, which will cost you as well money. So that will reduce the profitability of the of that particular reaction to produce that product. Can we improve the atom economy? Of course we can. So usually the industry tries to improve the atom economy and reach as much as possible to 100% atom economy. To do this, we can find other pathways to the same reaction to give higher percentage of the product. And higher percentage means that this reaction pathway will give you the product exclusively without any other side products or without waste. Or we can also make good use of the waste. So if you can find ways to use the waste so it becomes a useful product as well, useful in a different way, but useful, then that means that you can improve the atom economy. The last thing we are going to discuss in this video is the percentage yield. So yield is the amount of the product that you get. When the more reactant used, the more yield you get. The percentage yield, however, doesn't depend on the amount of the reactant used, it's just a percentage. So in order to calculate the percentage yield of your product, you need to find the mass of the product that were actually made, and you divide this by the maximum theoretical mass of the product, and you multiply by 100 to find the percentage. When you do a reaction, what we always assume when you do our calculation is that the reaction will give you 100% the product. However, this is not the case. So we're going to end up with less product than what you expect. The percentage yield can vary between 0 to up to 100%. So 0% yield, that means that no product was formed at all. And 100% yields, that means that all the expected products was obtained. So industrial processes should have the highest possible yield to reduce the cost and waste and to improve the profitability. And we can have an example now to find out how can we calculate the percentage yield of a certain reaction. For example, when 4 grams of copper oxide reacted with methane gas, 2.8 gram of copper was produced. So what would be the percentage yield of this reaction? The relative atomic mass of hydrogen is 1, copper 63.5, oxygen is 16. First thing you need to do is to write the balanced equation for this particular reaction. So 1 methane react with 4 copper oxide to give you 4 copper plus 2 water and 1 carbon dioxide. So in order to do this, first of all, we need to find the relative formula mass, calculate the relative formula mass for copper oxide, which is 63.5 plus 16, so this is 79.5. And then we need to change the MR into the number of moles. So we need to find out how many moles is that for the copper. So the moles of copper that have reacted. So we know that 4 grams of copper reacted. So the number of moles is 4, which is and the number of moles will be the mass over the formula mass, 97.5, so there is 0.05 moles. So when you look at this reaction, 4 moles of copper oxide will give you 4 moles of copper. That means 0. Or 0.05 moles of copper oxide should give you the same number of moles of copper. So number of moles of copper that should be produced if there is 100% yield is 0.05 moles. We need to change these moles into mass to find out what's the theoretical yield or the maximum mass of copper that should be produced. So the maximum mass of copper or the theoretical yield will equal. So now we need to find the mass. So the mass will equals moles, number of moles times the relative formula mass or relative atomic mass because this is copper. So 0.05 times 63.5, which is the relative atomic mass for the copper. And then you're going to find that there is 3.19 gram. So 3.19 gram should be the maximum yield of the copper from this reaction. But we actually only got 2.8 grams. So we didn't actually get 3.19 grams. So percentage yield for this reaction will equal the mass we actually got, which is 2.8 over the maximum or theoretical yield, which is 3.19 times 100. So you're gonna find that 87.8%. So this is the percentage yield for this particular reaction. So as you can see here, the percentage yield or the amount we got is not 100%. So why we could have a less than 100% yield? There are several reasons for that. The first one is that not all reactants will react to make the product. For example, we have what we call the reversible reaction. In a reversible reaction, you have an A and B, so like A and B as a reactant that will react together to give you C and D, and then the product C and D can react together again to give you the reactants. So that means that not all the reactants will actually give you the product because the products themselves will react back to give you the reactant. So this is one of the reasons why the percentage yield could be less than 100%. The second reason is because of side reactions. Side reaction, there might be some side reaction, meaning the reactants may react differently than what we expect, and they may give you other products other than the one that you expect. So the desired product you are looking for is produced in less quantity than the quantity you would expect from this reaction if it undergoes only one pathway to give you that particular product. The third reason is that some of the products also might be used, might be lost during workup. And workup is when you try to separate the product from the reaction mixture. So your product usually exists because most reactions take place in solution. So you need your product in a pure form in order to calculate its mass and calculate the concentration or calculate the mass and calculate the yield. So during the workup, which is the separation of that product from the reaction mixture, for example, during filtration, maybe some of the liquid might be left and maybe some solids as well might be left in the reaction vessel when you try to filter this one. In addition, you might also use some of the solids when you try to transfer it from the filter paper. In addition, when you try to transfer the reaction from one vessel to another, maybe from one container to another, maybe some of that solution will be lost. So there are several reasons why the yield may not be 100%, and usually we will never be able to get 100% yield of a reaction. The yield will always be less than 100%. The higher the yield, the better the reaction.